Problem 11. I need to find out value of this load resistance to get maximum power at load, as well as I need to calculate value of maximum power. I am following maximum power transfer theorem. First I need to find out the open circuit voltage. So load has been removed and voltage here is the open circuit voltage. See here, this point and this point, potential across this point is the open circuit voltage. The rest part are same. Now simplify this circuit, getting 2 points. This is A and this is B. Converting the left side of this AB into a single voltage source and a single resistance by using Thevenin theorem. So if we convert this into a single Thevenin voltage and single Thevenin resistance, it will be 20 volt and 10 ohm. Say if we open the circuit from here, the circuit looks like this. This is the current source, which is 2 ampere, and this is 10 ohm. So what is VTH? The current flowing through this 10 ohm resistance. So here current is 2 ampere. That 2 ampere will flow through this 10 ohm resistance. So 10 multiplied by 2, that is 20 volt, that is VTH. See here 20 volt is VTH. Now to calculate RTH, this current source will be open. So ultimately 10 ohm is RTH. So this is RTH here. So this circuit, this part of the circuit has been converted to this part of the circuit by using Thevenin. Keeping this part same, this below circuit is equivalent of above circuit. So now to calculate VOC. What is VOC? VOC is potential at this point with respect to this point. So in between these 2 points, what are there? That will be the summation of potential drop across this 2 ohm resistance and this 10 volt. To get potential drop across this 2 ohm resistance, I need to find the current flow through this 2 ohm resistance. So what is the current flow through this 2 ohm resistance? The current will flow in this loop. So 2 sources are here, 20 volt and 6 volt. See here, this is minus plus, this is plus minus. So if we consider 20 is positive, this will be negative. So equivalent voltage is 20 minus 6. So this is the circuit voltage, and the circuit resistance is 10 plus 5 plus 2. 10 plus 5 plus 2. So this is the current flowing through 2 ohm resistance. That current multiplied by 2 is potential drop across this 2 ohm resistance. So this is potential drop across 2 ohm resistance, and polarity is this is plus, this is minus. So this is plus minus plus minus. So equivalent of this combination will be VOC, and that will be addition of this potential drop plus 10. So by using that, ultimately I got VOC is 11.64 voltage. So this 11.64 voltage is open circuit voltage. Now I need to find out RTH. So load resistance should be removed, and this is current source. So this current source will be removed and it is open circuit. This voltage source will be short circuited. So here this is short. So after that I got this combination of resistances to find RTH. It is very clear that here 10 plus 5, this is in series. So 10 plus 5, that is 15, is in parallel with this 2 ohm. So by using that, ultimately I got 1.76 ohm. This is RTH. So putting the value in equivalent circuit, VTH is 11.64, RTH 1.76 ohm. To get maximum power at load, value of load resistance should be equal to 1.76 ohm. So I have used RL as 1.76 ohm. By putting value in the formula to get maximum power, ultimately I got 19.2 watt is maximum power at load. Now checking whether my answer is perfect or not. See here in equivalent circuit, Thevenin voltage is 11.64 voltage, Thevenin resistance is 1.76 ohm. Load resistance I have used with the same value, 1.76 ohm. In main circuit also load resistance is 1.76 ohm. Now if the power at load in main circuit and power at load in equivalent circuit, if these two are same and the value is 19.2 watt, then it can be confirmed that my calculation is perfect. Running simulation. See, in equivalent circuit, power at load is 19.2 watt. In main circuit, power at load is 19.2 watt. So my calculation is perfect.